Welcome back, my global citizens. I am Pharaoh, and my co-host, is the Scribe, and this is our podcast, Stay Woke. Our podcast is primarily focused on awareness and resolution. So today we wanted to talk about the coronavirus. It's an existential crisis right now. So before we get started, I wanted to be able to address any issues because I really feel like the millennials right now.
Okay.
Yes, we're making this about the millennials.
Okay.
Don't take it as serious. So I wanted to address initially whatever you wanted to talk about at first.
Yo, I have so many questions, so
Talk
many
to me.
thoughts running through my head, but let's get into it. I want to talk about the coronavirus. Hey, yo, let's get serious, man. Come on.
All right. Well, I
Like-
found that video on IG, and I just wanted to show you this is how I feel you guys are taking the coronavirus. So just a little
Yo,
here.
this is very serious. I take this very seriously.
No, I got you. I got you. So what do you want to talk
quit
about,
playing,
Scribe?
quit
Talk to
playing.
me.
Man, I mean, where do I start? I have so
Anywhere.
many questions. Okay, first of all, I'm gonna just jump right in.
Jump right in.
Okay, so
Don't be scared.
coronavirus and black people.
Damn. Why we have to start there? Okay, what is it about coronavirus? I know our race think we're immune to that, but that just is just not true.
Okay,
but
so-
answer the question. I mean,
So
sorry, ask
okay,
me the
so
question.
first of all,
Yeah, go ahead.
it started off by saying, well, I mean, the trend was that black people can't contract it, right?
Okay.
And then,
So now you've printed a retraction since then, and,
then-
you guys
and
are
then-
now saying what?
because Idris got it, and then it was like,
Oh, damn! So it took for a celebrity
an
to get
NBA,
it. Oh, Okay.
and so we was like, all right, cool. But then it
Maybe
seems
black people
like,
can get it. Just
okay, maybe they can't, but okay, so now it's like, if you're young,
Sure.
you can like recover from it a lot faster, or that it's very difficult for somebody who's young to get it. But so I'm thinking, so if you're young and black, does that mean that you're immune?
I don't necessarily believe that makes you immune. I don't think the virus has any choice on what color it affects. Now, the age thing is a clear issue. But before we go there, I wanted to share a few things about the pandemics that have happened in our world since then, right? So
Okay.
this is probably the only pandemic you've been in at your age at this time, correctly?
Was H1N1 a pandemic?
Yeah, it was.
Okay, I was alive for that.
But pandemic, let's understand the word itself. So when it's just spreading locally in your area, it's an epidemic, right?
Okay.
When it spreads to other continents, it's called a pandemic, right? So
Okay.
now that it's spread to every single continent, it's a global pandemic. Make
I
sense?
see, okay.
Right, so that makes it a pandemic.
So
right?
epidemic is specific to an area.
A localized area or a
Okay.
region, and if it's a pandemic, that means it's spread to other continents. Yeah.
I see.
All right, rock
Okay.
out. So I want to go back a little bit of history because I think it's important I know you millennials never read if it's not really on, if it's not trending that day to even go back and read in history, it just probably won't happen. So in 1918 we had pandemics prior to that, the Black Plague, which wiped out a third of the European population, but I want to make it at least in the 20th century. So in 1918, the H1N1 virus hit, right? And that's what's called the swine flu. And it came from, and generally when some viruses make a leap from animals to humans, it's called spillover, right? Don't ask me how it got into humans. We may consume them, we may pet them, and not sure how the virus gets inside. But that particular virus affected 500 million people in the U.S. in the worldwide, and 50 million people died. And
Okay.
also 675,000 deaths in the U.S., right? So in that particular pandemic, what I want to address is the age range that it affected.
Right,
So,
I was saying, you need to get on my question.
Okay. Hostility already. This is why it takes time to educate the general populace.
Let's go.
So in 1918, right, this is the first bigger one in the 20th century. So under the age of 5, it affected majority of the kids under the age of 5, and from the ages of 20 to 40, your age range, right? It also affected a lot of the populace, and then 65 and older. So it was spread out throughout,
Okay,
right?
so pretty much everyone then.
But it's still 675,000 deaths in just the U.S. That was the pandemic of 1918. It also lasted 1 year, 1919.
oh, okay.
The next pandemic was called the Asian flu. and that was from 1957 to 1958, right? That's the H2N2 virus. So that first one in 1918 was
Mutated?
the H1N2. So the virus mutates.
Oh,
Viruses
dang.
don't give a fuck, right? Viruses are completely skank, and they don't give a shit, and they're hostile to the environment, and their only aim is to reproduce. But we'll talk about viruses later. But I want to answer your question as if the virus is targeting a certain age group. I want to show
Boomers?
you. Wow. Yeah. So I know you feel that the boomers need to move on, but the way to do it is not to kind of wipe them out in a pandemic.
Hey, I'm not saying it should wipe them out, but I mean, look at what it's doing right now. So it's pretty evident who's getting.
We don't have that many cases
most
here yet,
affected.
but this is just the beginning part of the pandemic itself, right?
Okay.
Let's get back to the facts. So in 1957, the Asian flu hit. 1.1 million deaths worldwide. 116,000 people died in the U.S.
Why was it called the Asian flu again?
Because it happened in Asia and in the Asian countries right there, and it was from the avian flu. So I think that it was a bird that actually it transmitted from some type of a bird over into the human, but they call it the Asian flu because it was primarily in the Asian population or in the Asian areas there that it affected more of the people, but it did get to the U.S.
Oh, okay.
Yeah. In 1968, the H3N2 virus, which was called, this is also kind of called the avian flu, but it's 1 million people worldwide and 100,000 people in the U.S. And this affected 65 and older during that time, right? Right. That's the age group there, right? But in 2009, right? The 2009, we had another form of the H1N1 virus itself. This time, 80% of young people were affected. This was just in 2009. And 60 people who were 60 years and older had an immunity.
Interesting.
Yes. And it affected over 60 million people worldwide. There were about 13,000 deaths. And about 600,000 deaths worldwide. So if you look at the trend, right, and the reason why I bring the history up, in 1918, it affected everyone across the board. In 1957, it was 65 and older.
Right.
In 1968 also. But in 2009, though, young people were hit pretty hard with that. 80% didn't have an immunity to it, and people who were 60 years and older did. So I don't think the virus really cares about age. I don't think it really cares about color or race. I think the virus...
Okay, let's go back to the
Sure.
one in 2009.
Sure.
The one that seemed to hit the young
Sure.
people the most.
Sure.
I mean, in what sense? Because even with this current virus, like a lot of the people that are being infected, I think are still young people, but they're not dying as much as the older people, right?
You don't know if they're infected because we don't have enough tests yet, right? So this is the key issue. We don't know. This is why you're in social distancing and isolation currently, right? You wouldn't be in that situation if we had a bigger grasp on what population was actually affected. Because people haven't been tested, the best way to contain the spread is to have people social distance and to stay at home.
Well, they're saying now, like the majority of the people that are testing positive are actually younger people. But the people that are actually dying from the virus are older people.
I can't say that for sure because I don't know if that's written anywhere. Where'd you get that from? Did you Google it?
Somewhere on the interweb.
So I want to say first to our global citizens, also to you, my scribe.
We can fact check that actually.
Yeah, trust the science, not what people say. Trust the science. Yeah, It's important. What else you got? So you have another question because I want to talk about.
I do.
Okay,
actually.
okay. We'll
so
get back to you.
I have a ton of questions. Hold
Sure,
on.
Okay.
Okay, so coronavirus, right?
Does that answer the first question about? I think the virus doesn't have the choice, right? We've had, in the last 20th century, 4 other global pandemics, and the age range varies between pandemic, and it doesn't have any preference for race. So I think what it is based on people's immunity. If you see the first one in 1918, it was the H1N1, and then in 2009, it was the H1N1 again. But I think because your grandparents and parents who lived during that time developed an immunity, so in 2009, those individuals weren't affected as heavily. But the younger generation was because they weren't born during that time. Does that make sense?
That makes sense.
Okay.
Just gotta figure out who's dying from it, but
Wow.
okay. So corona, right?
I'm trying to figure out, are you just trying to protect the millennials?
I'm not trying to protect the millennials.
I feel like the boomers and the Generation X's we're being replaced.
No. It's not a matter of replacing you guys.
Sure.
But,
I came across a hashtag boomer removers. I mean, just saying. No.
Hey, people be doing the most, right?
Okay.
Listen. I appreciate it. My parents are boomers. You know, I'm not trying to get rid of my parents. And I don't think anybody else
I would hope
is.
that. I would hope not.
But
Go ahead. Next question.
okay, yeah. So they say that the virus is not airborne, so wearing a mask really doesn't help.
So what is the question? Are you asking me wearing a mask really doesn't help?
Yeah, because I see people like now people are making their own masks. They'll take like a bandana and put it around their noses because you know there's a lack of like masks now, and I'm just like, okay, what's the whole thing with the mask? Do you need a mask or do you not need a mask?
So let me ask one question before I answer the question about the mask.
Okay.
What did you think you were doing with the toilet paper?
Um.
Like what I heard is that you guys were trying to make masks out of toilet paper.
Well, it was a rumor that spread. It started in
Wow.
China. Someone said that the same material that the masks are made out of is what toilet paper is the same material as toilet paper. So basically, if you buy, I don't know.
I searched for the video because I want to see how that was going to play itself out, right?
It was-
I want to see
I
you putting some
mean-
tape on a piece of toilet paper and trying to wrap that around your damn head, right?
Yeah.
Think it's going to protect you from the virus. So let me answer the question per se, right?
Okay, cool. Is
So-
it airborne?
Is it airborne? So the virus can remain airborne, I think, for up to 3 hours. But my point is this: they did it in a controlled environment. So, say for instance, we were in this room
Right.
and they sprayed the virus in this room in an aerosol because the virus is actually in a respiratory droplet. It has to be in some type of fluid in order for the virus to survive or live. So, if someone sneezes or coughs and the virus comes out of your mouth and lands on the surface inside of the fluid itself, the virus can remain viable. But if the virus itself dries, it probably won't last. It won't last for that long. So in a room that's no ventilation and it's just stagnant air and someone coughs in the air or sneezes, the virus can be viable then. But generally, if you're outside, you have air circulating in the room, so you won't. This is why enclosed areas like bars, pubs, clubs, that there's very little ventilation or circulation of the air in there, and it's in a closed, confined space. Someone sneezes or coughs in those areas, people are going to get infected.
Okay.
So back to the mask. So the masks itself are to protect people who are infected. I'm sorry, people who are infected from others. Meaning, if I have the virus
Right.
and I put a mask on and I cough, I want to capture all of my virus inside the mask itself and not let the aerosol get out in the public. But for other people, I don't. If you're not infected and you wear a mask, it's not going to help you. If someone sneezes that way, right, and that droplet gets on your mask, it's going to perfuse through the mask itself. It's going to get inside, right? Yeah, that mask won't help you this way, right? It's protect people from getting out that way. Usually the masks are what they call directional, that they protect you only in one direction. The higher quality mask called the N95 mask, which the 95 makes the ratings on, it's a rating on the actual filter itself, meaning that it can filter out 95% of particles of a certain size outside. That's why it's rated at N95, right? So the higher the mask rating, the better it is in protecting from particles from actually getting on the inside. But those are really expensive masks, and they're usually used for the medical professionals, and you can't buy too many of those in the local market.
See, now that's the kind of answer I'm looking for. See, now
Does that make sense?
It makes
right.
it
So
makes
people
absolute
wearing the
sense.
mask, I think if you're sick, you should wear the mask. It protects other people from being
Right.
infected, but not necessarily you.
Yeah, stop banging out the mask, guys.
Right.
Okay, so then you said something about coughing and then it landing on the surface. So that's like my next piece because I like going out and I like going to the gym and they close down the gyms and I know we talked about how
Social distancing
how
doesn't
sad
mean
that made
anything
me.
to you at all, right? Okay.
but I was extremely sad.
So
More
freedom
so
over
about
it's freedom over your life, right? That's the
Right.
issue. Like you have to sacrifice some freedom until we get control of not jeopardizing your life.
So
Talk
the
to
whole
me.
thing about it living on surfaces,
Sure.
they say that it can live up to, some say 3 hours, some say 8 hours. Like, how long does the virus actually
I don't
stay
think
on the
people really
surface?
know, right? I think as we're learning about, that's why I call it a novel virus, novel coronavirus. Novel just means new, meaning that viruses that mutate, we don't have a lot of information about how they operate. So as we develop tests and find out more information, then we find out about, how to actually combat the issue. So I think they share that information for you to be more cognizant about how you take care of cleaning your area, wiping your surfaces, and then someone actually has to sneeze or cough to get the virus out onto a surface itself. So social distancing helps between that. If you have people in your house that you don't really know, I think wiping down your surfaces regularly, your knobs, your doorknobs, your doors, your faucets, your handles, bags, things you bring in from the outside. But if you're self-contained and you've wiped everything down, you should be pretty much good. But you have to exercise social distancing, and you have to wipe down the surfaces. If that makes sense.
So that's just steps to take in order to be cautious, I guess.
Yeah, whether or not you know. So I think I don't want to focus so much and panic on much how the virus lasts outside your body, as opposed to taking precautionary measures to protect yourself. The more you don't know, the more the precautionary measures should be put in place, if that makes sense. Yeah, right. So clean your surfaces, right, regularly. Wash your hands for 20 seconds with warm water and soap, and then try to sanitize if you can.
Okay, so warm water, heat. Everyone's saying that in the summer this shit is going to disappear because it can't really last in the heat. And then I've heard people saying that, drink like regular warm water, like, just at a whim. Because I guess if you keep it hot, that shit going to die. So what's the truth about that?
So,
the whole heat thing.
So there's really no scientific proof consistently showing that. We've seen trends where viruses have a tendency to die down in warmer weather. But remember, there's other elements that are exposed. Like a virus needs an environment to live in. Right. It needs to have fluid. It needs to have the other stuff. So if it's outside in the wind and it's warmer, the tendency for the virus to die down is much, much more. But you can't count on that. And you can't predict that anyway. That's not scientific information. It's just we've noticed that in terms of a trend, but necessarily that's not, we can't count on that. And if the virus is sharp, like viruses are, and say the summer comes and it decides to go dormant, that when the winter comes, it will come back up again.
That's what flu does.
It will resurface. That's exactly what flu does.
Okay.
It mutates. So there's some similarities, though. What else? Or did I answer that question appropriately?
I'm good. I'm happy. I'm happy with those.
What you got next?
Last but not least, I'm going to throw in some conspiracy in here. But then, apparently the virus is out here for population control. And Apparently. It's apparent.
So we're targeting individuals to specifically release the virus to kill. I'm just trying to get the question correctly.
I mean, apparently the talks in the streets is that, it's killing out a certain population because there's just way too many people.
You trying to say the boomers? I mean, just go to...
I don't even want to say boomers, but it seems
that's exactly what you're saying is the boomers, right? You say a certain population of people, 60 and older, underlying diseases,
Right, which happens to be the people that are in power and the people who...
You do know you'll get old at some point in time,
why the mayhem and the panic.
That your current immune system will suppress over years as you grow older, right? So,
granted.
Right, so you'll become a boomer. Or
at some point.
Boomer-like.
And then maybe there'll be another virus swipe me out. I don't know.
Wow.
But
wow. Is that where we're going with that?
How true is this whole thing?
What's your next question, brother? Talk to me.
Population control.
I don't believe...
Was it designed by someone?
I don't think you can. And when we talk about virus, and that's a really good lead into the next section about what a virus is. Viruses just don't give a fuck, just to be completely honest. They don't... There's no way to design one genetically to actually target a specific race itself. If it does, there's no way to really control its deployment. So you couldn't control once it's released. Biological agents don't work the same thing as drugs do, right? They need your body to respond. So I would have to know a lot about either the black race genetically and then be able to target certain populations, but we're intermingled around the world. We've mixed races. So it'll be really difficult to design per se, and almost virtually impossible to design genetically and to control the release of a virus to target a current population.
Wait, say that again about it's not what? It's biological and not what?
It's not drug dependent, meaning that the virus depends on your actual body to help fight. To proliferate, to help grow, and when we want to fight the virus, we also need your body. So it's your biologics that we have to design it for. Drugs can be targeted, but it's still hard to control because I can inject you with something, right? Right, and then that could kill you, right? I would have to physically inject you with something. But if I'm giving you a vaccine and I'm waiting for your body to develop the immune response to protect yourself, there's no way to really control that per se. And you're taking in the actual virus itself through injection and through an oral or whatever the means of they're giving you the vaccine itself. But my essence is this: there's no way to design specifically a virus to target a specific population. It'd be virtually impossible to do so.
So when are we getting this vaccine?
The vaccine piece. So we'll talk about that in our last segment. But let's talk about the virus and the growth of the virus itself.
Okay, yeah. So what is corona actually?
Where
That's a
virus
good
comes from?
question.
That's a really great question.
Yeah.
You have all the millennial questions, all the conspiracy theories come out, right?
Okay.
Have you addressed all those?
Yeah, I'm happy. I'm happy.
Well, I'm glad you did because I have a few of my own that before we get into the.
Oh, you got your own?
Absolutely. So, just like I got the Cardi B song from the internet, I also hear, and this is what I want to be clear on. So, this is xenophobia. Do you know what xenophobia is? Can you please define that for our audience? Can you tell what xenophobia is?
It's when you discriminate against someone based on their nationality.
Right. So I don't want to call it a Chinese virus because it originated in China. Viruses don't really care where they originate from, because in the 2009 and the 1957 viruses outbreak, they happened in the U.S. and spread from the U.S. to other countries. So I don't want to call it a U.S. virus, a U.S. swine virus, but they originated in the U.S. amongst the military. So specifically, and you can fact check this, in 1918, the virus originated in the U.S. military.
Okay, the H1N1?
The H1N1 virus in 1918, right? The 1968 H3N2 virus also is the avian flu, also originated in the U.S. So I want to caution people on calling it a specific type of geographic or race-related virus, because viruses don't give a shit where they originate from, and they don't care how they spread. And if it was targeted toward a certain group, then whoever did it did a shitty job of targeting, because now it's a global pandemic in almost every continent on the planet.
Oh, so that was called the Spanish flu?
It's called a Spanish flu. Yeah?
Infected 500 million people.
It did.
About a quarter of the world's population at the time, the death toll is estimated to have been anywhere from 17 million to 50 million, and possibly as high as 100 million.
People that died during
making
that
it
time.
one of the deadliest epidemics in human history.
Yeah. So we're not there yet with the current pandemic, but I think we've learned a lot over the years, which I think this social distancing, keeping yourself at home, and isolation itself are means that we know to put in place that we didn't know earlier on for the other pandemics. So this is why we press so heavily to actually socially isolate yourself. And if you don't know you are symptomatic or have symptoms itself, I think the isolation piece helps to protect other people. Yeah?
Yep.
Awesome. So xenophobia. So I wanted to really kill that piece of it, that no virus knows where it's going to originate. It's hard to control. It's hard to say I'm going to target it to a certain population. You can't really do that. No scientists have had any means of being able to do so, and I've been in the business for about 29 years. So that's that. But I want to talk about these other things trending, like Kung flu. Dude, how does that help, bro?
That's number 45, though. That's his doing.
Yeah, don't call it Kung flu, bro. It's not a Chinese flu virus. It's because it originated there. Obviously, other people can get it. Hashtag boomer removers, right? Hashtag Corona party. Hashtag Chinese coronaviruses. All those things that if you say only incite panic.
Corona Bay. People are getting Corona Bays now. Did you hear that?
They also saying that the next generation will be quarantines, right? The crown generation, right? Coronials, right?
Oh, wow.
Yeah, so I just think that I think when we're scared, when people have fear, and there was an acronym I wanted to share with you that my college professor used to use. He said fear stands for false expectations appearing real, right? False expectations appearing real. Fear. So I think the essence of fear is that we may perceive things that we don't know, which is hence the importance of our podcast to bring about certain awareness and to demystify myth in the sense that people have run away with as facts. Right? So no more hashtag boomer removers, no more Kung flu, No more corona parties, right? Don't gather together to wipe out the next generation. That doesn't work that way, right?
Yeah, it's kind
Okay.
of crazy.
Okay. So I wanted to share some other facts before we move on to what a virus is. So today, there only been about 200,000 tests administered in the U.S. today, and about 300,000 people in the world have been affected, with about 15,000 people that have died. That's the current information. So what's happening in these cities is that we believe people are already infected, but we just don't know. So this is where
15,000 people have died in the U.S.?
no, this is worldwide.
Oh, worldwide.
I'm sorry, worldwide. Yeah, in
Okay.
the U.S., I think we're around. I can't remember what I did with the number for that.
Google
Yeah,
it.
just Google that and see how many people have died. I think that was around, the last I heard was close to 100. Might
me
be more
see.
than that. Maybe 130. But take a quick check of that. It's always good to fact check. But my point is that it's going to continue to grow and double. And I don't want people to be scared by the current numbers, because if you see in our past pandemics that it took a while, but a large population of people were affected in itself. Yeah? Mm-hmm. Talk to me. So currently
419.
419. So each week, I believe these numbers will continue to grow and double. And it's not because it might be because of new cases, but I think as we test more, we discover where people are at. And then as people die, of course, that's just obvious that they had the virus and stuff. Yeah?
Yeah.
All right. Any other questions?
So, okay, speaking about deaths, I hate death of any sort.
Sure.
But people are like, okay, in a country of 330 million people and only 419 deaths, why are we panicking?
Wow.
People are
So-
like, the flu kills more people every year.
They do.
Why are we panicking?
So say the number of Americans, there are 330 million Americans currently in America, yeah?
Right.
So let's do some math here. And say it only affects 1% of the population. That's still 3.3 million people that die.
That's a lot of people.
Yeah, that's currently right now. If it affects 1% of the population out of 330 million, you still have 3.3 million that die. We're only at not only, but there are 400 and something deaths currently right now. Right? So if it kills 1% of the population, this is why it's so important to social distance until we can test to find out who's actually infected. What I'm looking for is more of a rapid test to be developed, where everyone can kind of do like a home pregnancy test. You do it at home, you
Right.
find out whether or not you're positive, you isolate yourself. It controls the spread of the contagion. If you don't, then people are wandering around at random, not knowing whether, now if I don't show any symptoms, I'm asymptomatic, but I might affect someone else that's at risk. Right, so if you don't social distance yourself, it's not normally just for you, right? It's for other people that may be at risk of you being near them, even though you don't know or not showing any symptoms. Does that make sense?
It makes sense, yeah.
All right,
yeah.
awesome. Anything else? What do you got next before we get into the juice?
Okay. No, actually, I'm going to save this for later because this has to do with the vaccine, but
Okay.
I have a question about people that are asymptomatic and why we're not using their blood to create a vaccine.
Which is a really, really good question, and I want you to hold on to that question for later.
Okay.
But let's talk about how infections kind of come about in itself. So infectious diseases are disorders caused by organisms, either a bacteria, a virus, a fungi, or a parasite. Many organisms live in or on our bodies already. They're normally harmless or even helpful, but under certain conditions, some organisms may cause diseases, right? So you're not supposed to really have them inside of your body unless you need them. So bacteria and viruses I wanted to focus on today. Necessarily fungi and parasites, not so much. I think I wanted to segregate bacteria because we receive more bacterial infections than viral infections than we do anything from fungi or parasites. Is that okay?
Okay, so you're going to explain the difference between a bacteria and a virus?
And a bacteria and a virus. I'll
Okay,
start
cool.
off with that first, right? I think it's really important to tell the distinguishing difference between those because I don't want you trying to take antibiotics for a viral issue.
What about our cleaning supplies? Because a lot of them say antibacterial, not necessarily antivirus.
They do, right? So they don't know per se, but we know that the condition in which the virus needs to live, that 99% it can kill most of them, but you're not really sure on some viruses are more resistant. So unless we have the mechanism of a rate of kill, we don't know for sure. So what we do is base it on other viruses, but you'll learn later that viruses are strong and are smart and mutate. So sometimes they become resistant to some of the cleaning agents that we currently have. But what we do know is that the majority of the cleaning agents will help reduce the amount of virus or even kill some of them.
I see.
Yep. So it's always a preventative measure to help. Yeah.
Yep.
Does that answer the question? Mm-hmm. Awesome. So two of my scientific brothers. One is his name was Dmitry Ivanovsky, and the other guy, he was a Russian man in 1892, and the other guy was Martinus Beijerinck. He was a Dutch guy, right? And these two gentlemen are responsible for the discovery of the virus in itself, right? So earlier times, they were having a little difficulty with growing tobacco. And tobacco, they extracted nicotine, which we use now currently in our cigarettes. But they started finding some of the tobacco leaves and plants were actually dying. And these two scientists were investigating why the tobacco leaves were actually dying. So they had this filtration method, which is what masks actually do. But the masks are made of what they call porosity or pore size. So they have a size on the mask that actually eliminates larger size organisms from passing through, keeping them on the other side, and the smaller organisms that come through, right? So when they were filtering this, they didn't find any bacteria that was causing the death of the tobacco leaves. But in the sap that filtered through itself, they did discover that it was a virus that was inside the actual sap that was smaller than the bacteria, which then led to them understanding that there are differences in sizes between bacteria and viruses. Does that make sense?
Oh, okay.
So bacteria are microscopic single-celled organisms that thrive in diverse environments. The organisms can live in soil, the ocean, and even inside human gut. So we need bacteria to some extent, but too much of anything will end up causing a disease, right? So our relationship with bacteria is a little bit complex. Viruses, on the other hand, we really don't need them at all and don't live off them at all. But the name virus is a Latin word which means slimy liquid or poison. The earliest indications of a biological nature of viruses came from studies in 1892 by Dmitry and by Martinus, right? They were guys that actually discovered it in the sap of the tobacco leaves. But yeah, the word for virus means slimy liquid or poison, right? Okay. Bacteria and viruses both are microscopic, but they differ. So a bacteria is larger in size and found naturally in our bodies and the environment. They can also survive without a host, which is going to be a key element in my dialogue later on, because viruses can't survive without having a healthy host, which in this case happens to be human cells. Right. So it actually invade the human cells, and the bacteria don't have to invade the human cells in order to replicate and to grow. They're in a sense self-sustaining, so they're considered to be alive. And viruses not necessarily are alive because they actually need the host to replicate. Yeah,
I see.
Host cell. Yeah. So early on, they could be seen by a microscope, which I have here.
Okay.
And in our microscope, the microscope was developed by having a lens at the top, and then a funnel, and then a lens at the bottom. And what scientists noticed is that when they looked under the microscope at items that were really small, it magnified them. It made them bigger. So I think the microscope was invented in the 16th century by a guy named Hans and a guy named Zachariah, right? Okay. Fact check me, please, because we like to fact check all damn day. That's how we roll, right? Mm-hmm. So viruses are smaller in size, and they require a host. This is why they're really tough to kill, because they get inside our actual healthy cells inside your body, hide, replicate, and then burst. So when you're trying to develop a vaccine or something to kill them, you have to do it without killing the host cell.
Absolutely. So the microscope was invented by Zacharias Janssen?
Zachariah Janssen,
Mm-hmm.
And
in the 16th century.
Okay.
Dutch guy.
Okay.
Yeah.
So to replicate inside and burst inside and attack others. So what the virus actually does, it gets inside your host cell. So I wanted to do a little demonstration here.
Okay.
Right. So let me move this over to the side so we can see. So this is the virus itself. Coronavirus. So the coronavirus is called the coronavirus. It's called the coronavirus because viruses have what they call protein spikes. These protein spikes are all around the actual virus itself, and they shape in form of a crown. And in Latin, corona means crown. Right? That's why they call it the coronavirus, right?
Okay.
Right. So the virus itself, what it does, and viruses are slick. Bacteria can actually circulate in your blood, but viruses, they need the host cell in order to live. So what they do, they come and they get inside of the host cell itself, And then inside the viruses, they have what they call genetic material. It describes how to replicate, how to grow. That material then actually enters inside the actual healthy human host cell, gets inside, and actually begins to replicate. Once it completely replicates, it bursts the cell open. The virus then circulates in your blood and finds another host cell to actually infect. So that's why it takes a few days before you to see any symptoms from the, because it takes a little while for the virus to infect multiple cells inside your body. So that's why they say over a 2-day to 14-day period, you should see some symptoms, because the virus probably has already infected your body, but you won't see any actual physical symptoms until the virus replicates enough to start causing some damage inside. Does that make sense?
I see.
Any questions?
Okay, so it seems like it takes a while after you get infected for the virus to actually show any symptoms.
It does. That's why they say self-isolate when you don't know, right?
Huh.
So if you had a test, which I'm advocating more tests, then you can actually figure out exactly who was infected, isolate those individuals until we can find a viable cure. Yeah?
Makes sense.
Yeah. So again, the virus in itself. So just a little bit more about the virus. So once it infects the actual cells, the virus likes to get inside the host cell itself, live there really well, and then burst and then affect other cells. So I wanted to show you a little bit about where the virus actually likes to reside. Right. So the virus will enter in either through your eyes, through your nasal capacity, or through your mouth. Right. This is where the respiratory droplets. So when someone sneezes, you either inhale it, you rub it in your eye, you get it in your mouth. The virus likes to make its way down to your esophagus in your throat, and then it eventually affects the lungs, right? So this virus is a respiratory virus. All coronaviruses are respiratory-like viruses, and I'll explain to you what that actually means.
So that's why they say don't touch your face.
Your face,
because
your nose. Because if
Exactly.
the virus is on your hands and you touch your eye, your nose, or your mouth, right? There's a possible entrance for the virus to enter into your body. Yeah. Awesome. Not awesome, but
Yeah,
So,
informative.
the origin of coronavirus. Normally, they're found and they circulate in a wide range of animals. So, corona, we've known about the coronavirus itself, the
bats?
species of coronavirus itself, not necessarily bats per se, but sometimes viruses make the jump from animals to humans, and that's called what we call spillover. Now, the reason why they make, I'm not really sure. I'm not going to say people are eating these type of animals. Don't
Are
look
they not,
don't look at me like that, bro. No one can prove that. All I can say that the term is called spillover. So remember MRSA or MERS, right? This is the Middle Eastern respiratory virus itself. This was transmitted by camels. Right, that was in the Middle East itself. So it's Middle Eastern respiratory syndrome, but that also attacks the respiratory system. This is another cousin of the corona, or is another variation of the coronavirus. Then we have SARS, which is severe acute respiratory syndrome. This was transmitted by civet cats. Right, so the first one was by camels in the Middle East. This one's by civet cats, and then now we have COVID-19. Now they think that the virus originated in the seafood market in Wuhan, Japan. I'm sorry, Wuhan, China, and the animals that they look at are pangolins and bats. Now, not sure. I know you said I'm not sure how they transmitted, but that's the thought process. We haven't defined the origin of them as of yet, but we do know it's still part of the corona family. Yes.
Yes. So, I mean, I don't know how true this is, that the coronavirus is actually a mutation of the SARS virus.
It is.
Okay.
So it's part of, so viruses are really sharp in a sense. So and this is why it's really hard to kill some of the viruses, because they do mutate and they become resistant to some of the vaccines that we currently have. So when we develop a vaccine, we really want to, on the first pass, make a strong vaccine itself, so that if the virus does mutate, that your fighters in your body can fight them off. But so it's a mutation. That's what viruses are so. So let's take, for example, the flu. You get a flu shot every year, right? And the reason why you have to get one every year is because the virus sometimes mutates. So what they do, they take inactivated or activated versions of the virus itself, depending when they isolate the strains per year, and they give you a dose of that. Your body then makes antibodies to that, or fighters to that, and it remembers.
Right.
So when you are infected with that same type of virus itself, it fights it off. So you may have been infected again and never really know it because your body has fought it off. But when you get a new strain, which happens to be the issue with the flu, you again begin to show symptoms like runny noses, a cough, headaches, sometimes pneumonia.
I see.
Yeah.
Okay.
Right. So the type of viruses that cause respiratory, the types of coronaviruses, they cause respiratory and gastrointestinal issues. Respiratory could be a common cold, a pneumonia, some milder symptoms, or it could be severe acute respiratory syndrome like SARS. So in China, it broke out in 2003, and it infected 8,000 people worldwide, and it killed about 800 individuals. The Middle Eastern Respiratory Syndrome, MERS, originated in Saudi Arabia, and that was in 2012. And that infected about 2,500 people and killed about 858 people
Okay.
before we got it under control. There's still no current cures for those, but we've contained the virus itself.
So let's talk about testing, right?
Okay.
And all these tests. And
Yeah.
why don't we have enough tests? Is it true that if I hold my breath for 15 seconds, I don't have the virus?
So,
And all these theories on how to self-test.
so if you did hold your breath, how would you know whether you had the virus or not if you didn't test for it?
If I did hold my breath,
Yeah, you said because one of the theories running around was that if you hold your breath for 15 seconds,
15 seconds,
that you would eliminate the virus,
no, that you don't have the virus.
or that you don't have the virus.
Yeah, this is like me self-testing myself. Like,
So if you don't cough.
if I don't cough, right?
So do know that the 3 symptoms of the coronavirus are that you have a dry cough, you have fever, and you have shortness of breath, that you need all 3 of these to be diagnosed with the coronavirus.
You need all 3?
You need all 3.
Okay.
So this defunks the theory about a cough solely, right? Holding your breath won't do it, won't give you a diagnosis. Because the virus, you can't tell whether you have a virus by holding your breath. You need to actually analyze the sample from inside of your body, grow the virus in a way that shows that, and then we have to identify its morphology or its shape, how it looks, yeah?
Okay.
All right. So again, transmission is done through respiratory droplets. And if you're in close contact with someone that's infected, some of the prevention measures I want to reiterate again: washing your hands and sanitizing with alcohol-based products, social distancing, millennials, no gathering. You don't really know. It's important. Let's play my favorite game, brother. Fact or fiction?
Fact or fiction?
Let's go.
Let's go.
So, fact or fiction? 500,000 Americans die from preventable diseases each year.
500,000.
5.5 Americans.
From preventable diseases. Fact?
That is actually fiction. Actually, 3 times as much. 1.5 million Americans die each year from preventable diseases.
Oh, wow.
Fact or fiction? 500,000 actually represents the number of children under 5 who die from who die from preventable diseases. That number. So that 500,000 actually represents the number of children under 5 who die from preventable diseases.
Under 5. Fact?
That is a fact. Why did you think that was a fact?
Because you said 1.5 million die in total, and I just, assumed a third of them would be kids.
Right. So measles, mumps, tetanus, diphtheria, pertussis, we've all had vaccines or cures for those diseases for many years. But the anti-vaxxers, right, people who do not vaccinate. Now, I want to talk a little bit about this, right? Do you know anyone that's an anti-vaxxer that doesn't want to take a vaccine?
Not personally, but, there's been a lot of social media, I guess, attention, regarding that specific topic. There's a lot of theories surrounding that topic
Sure.
as to, vaccines, what they do, and what's, people don't trust it anymore. So, yeah, to answer, I don't know anyone personally, but, yeah.
Sure.
I know that it's a thing.
So my thought process is this, right? So if you are an anti-vaxxer, that you feel that vaccines will hurt your child or you yourself, no issue if you resided in isolation where you didn't intermingle with other people in the public or in the crowd. If you stayed at your home, you self-schooled and worked from home, because then that way you wouldn't affect other people. But if you don't vaccinate and you carry that bug or bacteria or virus into a school, into your workplace, you're going to affect other people. people. Now, if you don't want to vaccinate yourself, that's fine, but then you can't go on and go into public places and infect other people without thinking, that there's some kind of fault of yours. So that's the anti-vaxxer issue. They feel that the vaccines aren't made safely enough. But to me, some of these key diseases that we've eradicated from the planet years ago that are reemerging are because people are in hordes that are not vaccinating, and that disease or bacteria or virus is growing and spreading.
Okay, so now I'm thinking back about all the debates regarding that, and I'm remembering that one of the biggest things was that, vaccines cause developmental issues. In some cases, autism in kids, and that's why people were like against the whole vaccine.
There is no substantiated fact to that. There's no scientific paperwork that shows that, and you would have to find all the autistic kids to see if they were vaccinated, and then equate somehow by giving them that vaccine that caused you to have a mental development. There's no fact on that. So conspiracy theories are just that, conspiracy theories, unless they're backed by science. So I say, trust the science and not what people say.
Okay.
Yep. Fact or fiction? Vaccines are live viruses that they inject into people.
I don't know. I'm going to go fact.
So that is a partial fact.
Okay.
And so I'm going to leave it there, because I think in our next segment, when I discuss about vaccines, you'll understand why that's partially true.
Okay.
Yeah?
I like that.
All right. Fact or fiction? The majority of people who get vaccinations or get vaccines get sick or die.
The majority of the people?
Mm-hmm.
Fiction.
That is fiction. Majority of people don't have any adverse reactions to it, but you may get a little response to that. And I'm going to tell you why it's important that you do later on when I talk about the development of vaccines. Yeah?
Yeah.
Awesome. Fact or fiction? Giving a child multiple vaccinations at the same time increases the risk of having side effects and overloads their immune system.
Fact?
That is actually fiction. Right?
What?
Yeah. So some of the vaccines that are made, they don't have any of the live viruses in them at all. So your body just makes antibodies to protect yourself just in case you get it later on. Now, there may be some reactions that you have, but not enough to cause disease. Yep. So I want you to look up the word.
Okay, why then do they, I'm just thinking about my experience when I was a kid.
Sure.
Because I didn't get all my vaccines at once. It was like you went a few times. At a certain age, you got this one, and then later on, you got the next one, and then...
You're right. Some of the vaccines, right, they need to give to you space out, and some of them they don't, right? Because some of them, they know that which ones, so over a period of time, they develop a vaccine regime where they know that earlier on when you're 6 years old, we can give you the ones that are inactivated, that are not live, and then when you get older, we can give you the live ones, or partially live ones. And I'll tell you why you need the partial live vaccines injected into your body.
Okay.
I know that sounds crazy.
Right.
It sounds crazy in general, but you need it for a purpose. So they space them out. So the ones that are inactivated, they can give you multiple doses because they don't cause any effects in your body. But the ones that are live, they space them out over a period of time as you grow older, because they know your body needs to respond to that in order to develop. We'll talk about it. Yeah.
Immunity.
Yeah.
Okay.
Yeah. Last one. So I wanted to talk about the body's defense system. So to give you a key before we get into the next segment, which is very important in terms of how we fight off diseases in the human body itself. So the body has a defense system. So everyone has an army inside your body. This army is specifically posed to fight off any diseases that you have. Now, I want to be very clear that people randomly are, I want you to look up the word antigen first. Antigen. Look that up, and I'll keep telling you about this piece. So the body has a defense system, right? You have an army. And in your army, you have what they call your B lymphocytes. Right? Your B lymphocytes are the ones that when any foreign subject enters to your body, it attacks it right away, it grabs onto it, and holds onto it for a minute, right? And then it starts making antibodies or other soldiers that can fight it off. But as it holds on to this foreign object, it signals over to your T lymphocytes and say, hey, T lymph, take a picture of this guy or this antigen in there so we can remember if it ever invades our body again, we can attack it again. So there's two pieces to your army. You have your B lymphocytes, which recognizes the antigen or the foreign object that enters your body, grabs onto it, hollers over to your T lymphocytes, tells it to take a picture. It also tells the T lymphocytes to take a picture and then call the other troops in to kill this foreign object that's inside our body. That's how your biologics works. That's how our immune system works. So when you have a new virus that's introduced into your body that's not recognized by your body itself, your B lymphocytes, your boss ones, grab onto it, hold on to it, and signal to the T lymphocytes, hey guys, we got a foreign person in our body, take a picture of him, and then send the troops to kill him. When they send the troops to kill him, some of the viruses are a little stronger and more resistant than your body can actually fight off. Right? This is why they end up infecting more of your cells, and your immune system becomes suppressed because your body's at war with the virus on the inside. So that's sometimes why you don't see symptoms for a little while, because what's going on is a huge World War battle inside your body to eliminate. So when you start seeing symptoms, it means your body's losing.
I see.
Yep, it's losing to the virus itself. It hasn't had a chance to replenish its troops. Like, people have been bombed and knocked out. The war, the battle's going on. So when they say you're battling a sickness or illness, you really are. There is a true battle going on inside your body. Your B lymphocytes and your T lymphocytes. So whenever go ahead.
The definition of antigen in immunology, antigens are structures specifically bound by antibodies or a cell surface version of a B cell antigen receptor. The term antigen originally described a structural molecule that binds specifically to an antibody only in the form of native antigen.
So that all means, to break that all down, is that whenever an antigen is any foreign pathogen or something that enters into your body, it's called an antigen because on your army will be able to recognize a foreign object. It says, hey, something's entered into our world or in our area that doesn't belong.
Okay, here's a simpler definition.
Okay.
A toxin or other foreign substance which induces an immune response in the body, especially the production of antibodies.
Right. So the antibodies are also your defense mechanism, right? So they created when your B lymphocytes recognize you have some foreign object inside your body right now. So when the virus enters in, your B lymphocytes actually, grab onto it, connect to it so they can make antibodies against it. But sometimes the antibodies aren't strong enough to defeat the actual virus. And the virus is slick. Remember I said it gets into your healthy cells and hides and replicates inside your good cells. So if your antibodies start fighting your good cells in your body, it starts to have effect on you. You start to, this is what they have called autoimmune diseases, right? Do you know what autoimmune disease is? Can you look that up for our global citizens and stuff? And I'll read to you this phrase. Whenever the antibody or antigen interlock, the antibody marks the antigen for destruction. So your B lymphocytes grabs onto the antigen and marks it for destruction. The B lymphocytes are powerless to penetrate the cell, so the job of attacking these target cells is left to your T lymphocytes, right? It can't pierce the virus. So it says, hey, take a picture of this fool inside me and then send some troops over to kill it. The T lymphocytes are cells that are programmed to recognize, respond, and remember the foreign pathogen that's inside your body.
Makes sense.
Now, we've learned this as scientists from looking at cells in what we call here through the microscope. We were able to identify some viruses and bacteria, but the other issue is that we're able to grow the cells, the viruses outside of the body in what we call Petri dishes. And this red fluid in there is really the medium or nutrients. So like a plant, it needs water, dirt and sunlight. So those viruses and bacteria need food, air, and so the medium is a great area for it to grow in. So for viruses, when they enter into your actual healthy cell, they take the material inside your cell and use it to replicate. And then that's what kills the cell itself, the healthy cell you have, because the virus is the savage. It gets inside, and not only does it invade your house, it goes into your refrigerator, start eating your food, kicks its feet up, start watching Netflix, and then takes over the entire house and kicks you out of the house.
Dang,
that
so rude.
Virus is rude.
So an autoimmune disease is a condition in which your immune system mistakenly attacks your body. The immune system normally guards against germs like bacteria and viruses, when it senses these foreign invaders, it sends out an army of fighter cells to attack them.
Right. So your body can be fooled sometime, thinking that it has a foreign invader, or it recognizes the
So
cells have.
viruses that's a new piece of information that I didn't know. So
Yeah.
they can hide themselves in your good cells.
They do.
And then your body will attack those
This
cells.
is why it's hard to kill and give. That's why it's hard to kill viruses that enter into your host cells, because there's no way to really kill the virus without killing the host. So this is the problem with HIV. Right, because the HIV virus gets also in healthy cells and hides itself and replicates in your tissues and in cells itself. So if we develop a vaccine against it, we have to find a way to separate. Or either what they've done, and a lot of these vaccines now are really targeted toward the replication process. So before the virus actually enters the cell, it attaches something to it that when it gets inside the cell, it's not able to replicate itself. So it becomes what they call inert. Or not able to.
So it's like paralyzing.
It paralyzes it. Doesn't allow. So all the vaccines and drugs that are cures affect some type of biological function. This is the difference between drugs, which target the direct issue or target the direct bacteria or virus and kills it on site, as opposed to using your own body in order to fight the disease off. So vaccines invoke what they call an immune response. They force your body that when I enter in a foreign substance, the B lymphocytes recognizes, hey, we have somebody foreign in here. Grab onto it, take a picture of lymphocytes, and send your troops in order to kill it. That's the way your body works. But that fight can deplete your immune system over a period of time, which then makes you susceptible to the actual virus itself, and then you start showing symptoms.
So much key information today, Pharaoh.
Anything about viruses? Any more questions about viruses?
No, I mean, there's a wealth of information, but I am so happy with everything that you've just said today.
Very good.
So much. I think the audiences will feel the same way too.
All right, let's take a break right here, and then let's come back with vaccines. One, how are they made? Why we need vaccines, and then subsequently how they're approved. Let's take a break.